Alright, let's start off with something relatively simple. So let's say that I give you the function f of x equals to 1 over 1 minus x. And I wanted to turn that into a power function. Well, when I look at that, maybe, obviously I've done this before, so I see it and it's very obvious for me. However, before I even tell you, does this resemble anything you've ever seen related to series in any way? Geometric how? This looks just like that formula. This resembles this right here. If you have a geometric series in the manner that is a times r to the n, well, this looks a little different from the one that I showed you in pre-cal. The one that I showed you in pre-cal was a times r to the n minus 1, but this one says a times r to the n. Why would this still be considered a geometric? It has to do with your index. Remember the index, the other one that I shared with you in pre-cal started with 1 to infinity. So because we're starting with 0, we can get rid of that minus 1. Well, if you remember, there's a formula for this that tells of a geometric sequence that goes to infinity. It is going to be the first term divided by 1 minus the rate. Where the rate, and here's what my pre-cal forgot on this test, the rate has to be less than 1. You guys recall that? Well, if you look at this, this looks pretty much the same way. And it kind of tells you a few things about it. First of all, it tells you that the first term would be 1. And it tells you that the rate would be x. Agreed? Therefore, could you make this into a series? Yes, you can. The series from 0 to infinity of the first term times the rate to the n power. Agreed? Now, if we expand this out, let's say we expand it a little bit. So if we plug in 0, what do you get? 1. If you plug in 1, you get x squared, x to the third, dot, 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 right? X to the n. Alright, we have a problem though. When will this series work? When the absolute value, right, it's less than 1. But when will this function work? Always. Except for 1, right? But this, you can look at the entire domain except for one value. This, you can only work for a certain interval. And hopefully you know that that interval, because your rate in this case is x. So the absolute value of x has to be less than 1, right? Which means that this can only work between negative 1 and 1, which means that your interval of convergence would be negative 1 to 1. Why would I not need to test my endpoints in this one? It's geometric. You know that putting 1 in there will no longer work. Putting negative 1 in there will no longer work. So don't waste your time testing the endpoints, okay? But what if I wanted to work outside of this? Well, everywhere else it diverges, right? But I wanted to make sure that it works. I want to find out a series that would also work for this, but outside of this interval. Like, what if I was interested in finding out what f of 2 was, right? F of 2 is definitely not within that interval, but I should still be able to get a series that can help me out. Well, remember, ever since we started doing the second part of chapter 9, it's all about approximations, right? So this thing is going to help you do an approximation, a pretty close approximation of anything that's between negative 1 and 1. Well, if you think about that, what is in between negative 1 and 1? That means that that's the center of your series. So what if we switch the center to whatever we need it to be? And that's going to be the challenge here. We can move the center anywhere else we want it to be and make it work. Okay? That's eventually what we're going to do. I only got about 3 examples to share with you, and then we're done. Sweet? Alright. So we're going to take the exact same problem. Okay? So we're going to say I have f of x is equal to 1 over 1 minus x. But this time I'm going to be centered at, let's do negative 1. Okay? So this is a completely separate problem. So example number 2. So I have that same function, but this time I'm going to be centered at negative 1. Ready? Okay. Well, this thing still looks like what I want it to look like, right? A term on the top over 1 minus. Okay, that's going to be the key. It's got to be 1 minus. The problem here is that I need to find a way to center it at negative 1. If you did the homework last time, how could you tell that something is centered at a certain value? So when you were turning something into a power series, what would you do? Even a Maclaurin series, even a Taylor series, how would you know that the center was there? X minus something. So you're going to have to do that here. You're going to have to plug in the center here for x. So the center here for x, if you want to say that it's not center 0, you cannot say x. You have to say x, in this case, plus 1. You guys with me? But that changes this expression. So you have to balance things out. If you're going to add that plus 1, you got to balance it out with the rest of the expression. Here's what I mean. Well, we're going to have this 1 over 1 minus x, right? And we got to plug in, you said that x plus 1, right? So I am going to literally go in there and say 1 minus x plus 1, right? Are these two the same thing? They're not anymore because you did something here, right? So here's what you did. Because you added a 1 right here, you also have to add a 1 to this term. Okay? So that means that we have 1 over 2 minus x plus 1. Agreed? Now we got this thing balanced out. Okay? It's the same expression. Now here's the thing. Now by doing that, we've changed it. It no longer looks in the form of 1 or some term over 1 minus r. Do you guys agree? How can I achieve for this number to go back to being a 1? But then if you subtract 1, where are you going to subtract it from? Like, that's your expression. You don't have anything else. So the easiest way to do this without changing anything, by still achieving to have the same expression, we're going to divide by 2. And we're going to divide everything by 2. You guys okay with that? So that means that the numerator would become 1 over 2. Right? And 2 divided by 2 would be 1. And then you have minus x plus 1 over 2. Agreed? Bingo. We've got our expression. What's your first term? What's a of 1? 1/2. What's your rate? X plus 1 over 2. I want to make sure I haven't lost anyone. Are we okay? Remember, the top right here tells you what your first term is. Because it's 1 minus, that means that this is your rate. So give me, what would this look like as a summation? What would it look like as a series? To the n power. Now that we have it there, what would be your interval of convergence? Interval of convergence, I'm sorry. So the absolute value of x plus 1 over 2 has to be less than 1. Agreed? So we solve this out. That means that negative 1 is less than x plus 1 over 2, which is less than 1. If we multiplied everything by 2 and then subtract 1, right? What would you get? So your interval of convergence is going to be from -3 to 1, and it's going to be open. For all of this, it's going to be open. It's geometric, right? So this is your interval of convergence. So now, do you guys see how by the first example, I could find out any value between -1 and 1, right? Now I can find out any value between -3 and 1. So if you were looking for something else, you're gonna have to center it somewhere along with whatever you're looking for in order for you to use the series to evaluate. Cool? Questions so far? All right, moving on. I want you to find a power series for f of x equals 4 over x plus 2 that is centered at c equals 0. Because think about it, geometrically it's a power. It's a power series if you think about it. Alright, what do you guys think? Well, it's 0, so there's nothing we can change. Well, there's nothing you should change as far as that, right? X represents that it is centered at 0, right? Remember, our main goal here, the difficult part of this problem is you have to make it look like some number over 1 minus r, right? So, as it stands right now, what do you guys think I could do? So I have 4 over x plus 2. Are you okay if I just do that for a moment? Yeah. Same thing, right? Sweet. So if I divide everything by 2, I get 4 divided by 2 is 2. 2 divided by 2 is 1 plus x over 2. Agreed? You've almost achieved it. We have 1 plus though. I needed to say 1 minus. Sweet. What if I just say 2 over 1 minus negative x over 2? Is that the same thing? Say that one more time, sorry. 4 over 1 minus, in parentheses, -1 minus 7. Okay, that's fine. So now you're here, you should be able to now write down your power series. So your power series is going to be from 0 to infinity of 2 times negative x over 2 to the n power. Now, I'm going to be honest with you. When I look at this, it's probably not the answer that you would have either on the test or on the book. They're probably going to play around with them a little bit. Sometimes they rewrite them a little bit. They probably take out this negative, and the way to do that, you can't just take out the negative. It's like saying the following. I'm going to show you over steps to make sure that I don't lose you. That's the same thing as saying -1 to the n power, right? You guys with me? So it's like taking that out, and then you have this x over 2 to the n power, right? You still have the n power there. So that -1 is going to do what? Alternate. So this is going to be alternating. Cool. So I can see them doing that for this specific series. They might not. They might just be nice enough and leave it there. But if this didn't show up like in a multiple choice, then you might need to just play around with it until you can achieve it. Most of the time, anytime you see a negative in there, they're going to try to pull it out. Cool? How would you find the interval of convergence? Negative x over 2 is less than 1. So this one should be easy enough. So it's between 1 and what? -2 and 2, right? But you gotta multiply by 2. So that's gonna be your interval convergence. Interval convergence. Alright, one more and then we're done. I'll let you try this one on your own. And I actually want to show you something else that is kind of neat. Yes? How'd you get -2 and 0? Let's see. I see what you did. So you did this and you put it into another one, right? Let's try not to do that. I see what you're doing there. No, let's try to just use some way of, try to use like divisions and whatnot. By doing that, I see what you're saying, but then I personally don't know what happened and why this is not occurring. Let me see if I can find out why, but for now at least use division to figure out the rate. Cool? Last one, I want you to try this one on your own, and then there's one last thing I want to show you. It has to do with long division, so hopefully you didn't forget how to do long division. But here's the last example. So it's the same instructions. Find a power series, and here is your function. F of x equals 1 over x, and I want this thing to be centered at 1. Okay, so f of x equals 1 over x, and it is going to be centered at 1. Find the power series for that. Alright guys, check your answer for those of you that were watching the video. That's all I got for you today. Well actually there's one more thing I kind of wanted to show you. I don't feel like writing it down, so let me just kind of project the textbook so I can show you what they did. Here we go. On the textbook, this is one of the first examples that we did. So the one that was 4 over x plus 2. You guys remember that one? Okay. So they did all the process here that we did. But here's something interesting that I find it very interesting. It says, another way to determine a power series for a rational function, such as the one in example 1, so the one we just did there, is to use long division. So for instance, by dividing 2 plus x into 4, you obtain the result on the left. So remember, this is what we had, 4 over x plus 2, right? So they did it by long division. Here's the trick with long division. Well, with long division, you're going to get all the terms of the series, and then you're going to have to determine the sigma notation. But if you were to expand, here's what we got on ours, right? Remember that one? If they expand it, here, like if you start finding the terms, here's what you get. Which, if you compare those to what you get on the long division, is the exact same thing. So you can always use long division, but then your job is then once you have a few terms, then you're going to have to on your own figure out the rates, right? And you have the first term, so it shouldn't be that bad. And then you can write it in sigma notation. Honestly, I mean, it's pretty neat in my opinion. I would just go with our calculus way. I think it's a little faster than this. This absolutely won't work. I think on the homework there is 2 questions in there just so that you don't forget long division. Because if I'm not mistaken, earlier in the year we used long division as well. So I want to make sure you don't forget your long division. Okay? Alright, that's all I got for you guys today.